Hey everybody, how's it going?
Good, you.
Good.
Yeah, it's all right. Luckily, I don't know if I already said this yesterday. Did I mention one of my midterms got postponed?
Yeah.
Yeah, that absolutely owns to have 2 extra days to get ready for that test, man. That test is gonna suck. Anyway, here's what I got for you today. We have 2 parts to today's warm-up, and then after that, be sure to get your warm-up uploaded for the week. I'm calling this week 4 just because I'm going to count spring break in our counting of the week. Somebody is like slamming drawers looking for a pen so they can take these notes, I guess. Anyway, what was I saying? Oh, right. Today we have this 2 parts to the warm-up, and then make sure to upload your classwork for the week. I'm calling it week 4. Just because I'm going to count spring break as one of the weeks. It helps keep track of the time. And once you're done uploading both parts of the homework, you are free to head out for the weekend and go chill, as if that isn't already what we've been doing with most of our time. Item number 1, this quadrilateral, which I've called KITE, is a mathematically geometric kite, which has associated with it all sorts of properties. And here's what I'm going to tell you about it. KT is equal to 10, SE is equal to 12, and IS is equal to 5. I need to know the perimeter and the area. And this is directly related to our last set of notes. What was that set of notes about?
Pythagorean Theorem.
The Pythagorean Theorem, which is to say, even though this is about a quadrilateral, in order to get the answer, you're going to have to use the Pythagorean Theorem probably several times. And then after that, for item number 2, please look at that right triangle and solve for x. Yeah, solve for x. And just be forewarned, there are 2 answers. And what is that? How do you think that is? What kinds of equations give us back 2 answers?
Quadratic.
This is going to ask you to use the quadratic equation. So just a quick reminder for those of y'all who forget, for all quadratics of the form, 0 is equal to ax squared plus bx plus c. The answers to this problem will always take the form x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. In case you forgot from Algebra 1 last year, this is just the quadratic equation. This is the quick and, I wouldn't say easy, because you have to memorize it, and that's no fun. But this is like the traditional way to solve quadratics. Today, while we have the extra time, since I know that homework was probably easy for y'all, we're going to talk about an alternative to the quadratic equation called completing the square. Have you guys ever completed the square?
Yeah, I have.
Has anybody else out there ever mathematically completed the square? No? Okay. Well, the reason why I want to talk about it is that when I was a tender young 7th grader, memorizing this wasn't something that I was into, and every now and then I would forget it. I have another method which produces the exact same answers that we're going to go over today, simply because the quadratic equation, the quadratic equation and the method of completing the square, they're both going to give you the exact same answer, except I would assert that completing the square is a lot easier to remember. It's a lot easier to hold on to what the bits and pieces are up here in your brain. Take a few minutes to do these 2 bits of the warm-up, and then we'll get going. Okay. Now that we've had a little bit of time to work on this, just one piece of information I want to give y'all. Today, the College Board had a big announcement about changes to the SAT. I've been teaching while they put that announcement out, so I don't know what they are yet. But since it's of paramount importance to my honors junior class, the pre-cal kids, I'm going to be reading over that and watching a video, and then I'll post an SAT update later. Since some of y'all are still planning on taking the SAT in the next few years, I will also post that announcement to this class's Google Classroom, so that in case you were thinking about the SAT or worried about it, I just want y'all to have an opportunity to know what those updates are. Let's go ahead and start off. Yes?
Did they just release that? Because I got one from yesterday. Did they change the one from yesterday?
Yes, yeah. They've been waiting to do a live, oh my God, I hate this word, webinar. It means a seminar on the web. It's one of my most hated phrases.
Yeah,
It's horribly corny.
I understand why now.
Because they postponed it all the way to August, September, October, December. So
yeah, and the other thing that they changed on top of that is that normally it's only offered once a month, but from when they bring it back until the end of the year, they're going to offer it every weekend.
Yeah.
But past that, they were supposed to do a seminar today from 9 to 10. So I'm going to watch a replay of it after we're done here, like while I eat my lunch, and then I'll write up a little thing about it so that you guys don't have to do the work.
Okay.
Yeah, I think
Thank you.
I think my dad was saying they're trying to, like, if it gets like, they're trying to make like a something so you can take it at home, but it's like it tracks your like movement at home to make sure that your eyes are not like you're not looking anywhere else. But like that's probably until like if it gets to like a really bad point where like it's gonna be for a really long time, like we're gonna be in quarantine.
Yeah, that stuff is a bummer to me because I don't know, that just seems like a weird invasion of privacy, which is why I don't require you guys to turn on your webcams. Like, it's my class that I'm attempting to conduct. I don't need to make sure that all your eyeballs are here. That's why I make sure that y'all turn in the classwork so that I know that you're writing down some stuff from the class every day. And let's be real, if you aren't paying attention in class during lecture, who does it hurt? Does it hurt me?
No.
No, I get my paycheck either way. It hurts you. It'll come through when I grade them tests and quizzes, right? Yeah, I don't like the thought of there being an SAT at home where like the webcam is tracking your, that sounds like hell. If I was you,
but it's really hard to cheat on the SAT. Like, by the time you find one of the answers, the section for math is basically going to be finished.
Yeah, totally. It's by how fast you can go.
Right? Yeah. I don't think, like, at the point that you could cheat at the SAT and get a good score, I would assert that figuring out a cheating system and implementing it is more work than just studying for that test, man. That test really isn't that hard if you put the work in. Always be aware of that, of like, oh, hey, I figured out how to cheat this test. I just wrote the notes and then I coiled them up and I hit them in my pen. Well, it's like, dog, it took you like 3 hours to manipulate this pen and make it so that you could hide notes in it. What if you just like studied? Sometimes the easiest way is the most direct way. Hey, anyways, let's go ahead and start. So KITE is a geometric kite. And since it's a geometric kite, it has certain mathematical properties that we just like know about. What are those properties?
The two long sides are like congruent and the two like short sides.
I like that. Let's start off with those marks. So this guy and this guy are necessarily congruent. This guy and this guy are necessarily congruent, which is going to save us some work because now instead of having to do 4 Pythagorean theorems to get 4 hypotenuses, we know that once we do it on one side, it's done on the other side. What's another property of our geometric kite?
But the little cross inside, the KS and ST are congruent.
Right here where they cross, KS and ST are also congruent. Without that, we couldn't solve this. I didn't give you KS, I gave you KT. So we'll come back to that in a second. And there's one more thing we need in order to start this problem off.
The angles are congruent. It's a 90-degree angle.
It is true that these two angles are congruent to each other. It's a fun fact, but it's not useful. It was that second one. Then in the middle, these two are perpendicular. And if one of these is a perpendicular angle, all four of them are perpendicular angles. We have a theorem for that too, but that has to be true so that the Pythagorean theorem can be useful to us. So IS is 5, that I told you. Okay. KT is 10. So what is the length on each side? The whole thing is 10. Each piece is equal, so each one is
5 and 5.
5 and 5. And then I also said that SE from here to here, that's 12. And now we can go ahead and we can do the Pythagorean theorem 2 times in order to get the components that we need to answer this question here. So for this first part, we need ET. And so ET squared is going to be equal to what? What should I write?
ET is 5 squared plus 12 squared equals C squared.
Yep, the thing that we're solving for is going to be equal to 5 squared plus 12 squared. And does anybody recognize 5 and 12?
Yeah, 13.
Pythagorean triple.
Good, this is one of our Pythagorean triples. This is the other big one aside from 3, 4, 5, 5, 12, 13. But that's because 5 is 25, 12 squared is 144. Those two added together is 169. And the square root of 169 is 13. So that means ET is equal to 13, which actually gives us 2 lengths. This is 13 and this is 13. Now the only other length that we need in order to solve this is IT. That will give us that top length there. And notice that this is a special case. This is actually a special case that we'll be talking about on Monday. Not only is this top triangle a right triangle, but it's also what other kind of triangle?
An isosceles?
Very good. Notice that this length is 5 and this other length is also 5. So this is an isosceles right triangle. And on Monday, we're going to be talking about that special kind of right triangle and 2 other types of special right triangles. Next week on Monday and Wednesday, we are going to have the most consequential notes of the entire year. Next week, we're going to build the skills that we need to do actual trigonometry. And it all starts with special right triangles. Anyway, IT. Is going to be equal to 5 squared plus 5 squared. And I'm actually going to do something that some of y'all might not like, but consider the following way that I'm going to solve this. I'm not going to square these. I'm going to say that IT squared is equal to, what do I get when I take x and I add it to x? What's x plus x?
2x.
2x.
2x. So will you accept that this is 2 times 5 squared?
Yeah.
Is that okay?
Yeah.
Yeah, okay. So now I'm going to take the square root of both sides, which is going to give me IT is equal to the square root of 2 times 5 squared. Zoop. Okay. And 2 here, I can't really take the square root of that. That doesn't simplify. That's just going to be root 2. What is the square root of 5 squared?
5.
5. And I like this approach on it because this automatically simplifies it to a root form without us having to do any sort of combination and then simplification. Like if you got, oh, root 50, what is root 50? Root 50 is 5 root 2. And again, since I know that this is congruent to this side, this other side is also 5 root 2. And so what is our perimeter? What's the definition of perimeter, y'all?
26.
I got 10
plus 10 root.
10 square root 2 plus 26.
Yep. So 13 and 13, we can add those together. That's 26. 5 root 2 and 5 root 2 is 10 root 2. So the perimeter is 26 plus 10 root 2 units. And now we can also get the area. And we don't have an area equation for a kite, but any polygon can always be broken up into triangles. And for a triangle, the area is pretty easy. What's the area of a triangle?
Base times height divided by 2.
There we go, 1/2 base times height. So we're gonna say that we have two triangles here. I got this big triangle up top, and I got this even bigger triangle down below. For this triangle up top, it's 5 by, how wide is it?
10.
Cool. So it's gonna be 1/2, 5 by 10. That's the top triangle. And then down below, this is 12 by 10. So this is gonna be plus 1/2 of 12 by 10. And so the area of the kite overall is 50 over 2 is 25, 120 over 2 is 60, 25 and 60 is 85. Are there any questions here on item 1?
Nope.
Okay, one other fun fact about kites is, I don't know if y'all know, but old comic books are weird, man. Old comic books get strange. Did y'all know that the Green Lantern's original arch nemesis was a dude named Sportsmaster? And before the Green Lantern was weak to like yellow or whatever his weakness is, he was weak to wood. So like the Green Lantern, super powered superhero who can shoot lightning out of his ring and make objects and stuff, but his weakness was being hit in the face with a wooden baseball bat. Similarly, there is an old school, really whack supervillain named Kite Man. And guess what his power is?
He can fly a kite.
Flying.
Dog, he has a kite. That's his whole deal. He has a kite attached to his back.
That's it.
That's his, yep.
Oh my
Kite
God.
Man away!
Harley.
Yeah, Kite Man is bad, and every time he runs into Batman, he just gets destroyed, just annihilated in the most humiliating way. Anyway, old comics are weird, man. You can tell that certain characters are from the 1940s or 1950s when they're corny like that. Just like one of Batman's other terrible villains, Calendar Man. Have y'all ever heard of Calendar Man?
No.
On Easter, he'll straight up do like an Easter-themed crime. It's embarrassing. Hey, anyway, let's go ahead and solve a quadratic with the quadratic equation. And then I'm going to teach y'all to complete the square, which, you know, this is all technically review. It's stuff that you should be able to do all the way back from Algebra 1. I just want to make sure that we touch on it now because you will need to be able to do this next year. So it's good to, you know, try and keep up with those old skills. Step number 1, we're going to set up the Pythagorean theorem for this equation, which is going to cause it to kind of blow up on us. What do we get out there? How do I set that up?
So what I got was after like solving all the quadratics, I got
Nope.
x. Oh,
I just
before
want the
that.
setup.
Okay. X plus 5 times x plus 5 equals 4, and then you also have x squared before that, equals 4x equals 2x plus 1 times 2x plus 1.
So if we just take the bits and pieces that are off that triangle and we plug this into the Pythagorean theorem, we are going to get that 2x plus 1 quantity squared plus x plus 5 quantity squared, which is how you read something out like this. You say quantity whenever a parentheses ends. This is what we get from the Pythagorean theorem. Are there any questions just there? No? Okay. Here is the part where this gets messy, or yeah, this is the part where things get rough. X squared, that's easy. That's just x squared. What's this squared?
You have to FOIL.
X squared plus 10x plus 25.
Yeah, it's a quadratic.
Whenever you are squaring a binomial, you must FOIL it. X plus 5 is literally, I'm sorry, x plus 5 squared is literally x plus 5 times x plus 5. And so we have to go first, outer, inner, last. X squared plus 5x plus 5x plus 10 is equal, plus 25. X squared plus 10x plus 25. And if you can look at this and read that and write the answer in one go, great. If not, work it out on the side, because this is not equal to x squared plus 25. You cannot just square the two things inside of it. That is to say, exponents are not distributive. You cannot distribute an exponent. The same story applies on the left-hand side. This also must get FOILed. This gives us 4x squared plus 4x plus 1. Is that okay?
Yeah.
Okay, so now we have this mess of an equation, and whenever it comes to solving the quadratic, what do we have to set it equal to? What's the deal?
0.
We must set this equal to 0. We have to. We have no other choice. And so to set this equal to 0, we're just going to move everything to one side. So I'm going to clean this up just because we can clean up these x squareds. So this is 4x squared plus 4x plus 1 is equal to 2x squared plus 10x plus 25. And now I'm going to subtract all of this over. So that's going to give us 2x squared. And then 4 minus 10 is negative 6x. And then 1 minus 25 is minus 24. This is equal to 0. I can also clean this equation up and make it a little bit easier to plug into the quadratic equation. How?
You would have to factor out the 2.
And we don't even have to factor it out. We can literally just throw it away, because I'm going to divide both sides by 2, divide both sides by 2. What's 0 divided by 2?
0.
That's 0. And then on the left-hand side, we'll just get half of all of these terms. So it'll be x squared minus 3x plus 12. Minus 12. And now try as hard as you are able, but this does not factor. You cannot come up with two numbers that multiply to negative 12, that add up to negative 3. It's just, there's no sets that do that. 12 is either 1 and 12 and 2 and 6 or 3 and 4. The differences between those terms would be 11 or 4 or 1. There are no differences that give us back that 3 that we would need. So from here, this is our standard option. This is really all that you can do. So we're going to fit the pieces into that. So this is to say x is going to be equal to negative b, which is going to be negative 3, so 3, plus or minus the square root of b squared minus 4ac. So b here is negative 3. What's negative 3 squared?
9.
9 minus 4ac, so it's going to be minus 4 times a, which is 1, times c, which is negative 12, all divided by 2 times a, which again, 2a is 1. So we're going to get that x is equal to 3 plus or minus the square root of 9 plus, because the minus and the minus here will become a plus, 4 times 1 times 12, which is 48. 9 plus 48 is 57. So it'll be 3 plus or minus the square root of 57 all over 2. Is that okay? Are there any questions on that second part or the quadratic equation? I'm sorry, yeah, the quadratic equation. Yes, no? I'll take silence as a no. Okay, so feel free to turn in your warm-ups, but I just want to do a quick review today. I'm sorry, not a review, but a quick item of notes on the quadratic equation. just because I don't want y'all to be completely rusty when you get to Algebra 2 next year, versus the technique of completing the square. And to show y'all the reason why I think completing the square is cool, I'm just going to use that same quadratic that we just solved, just because we already know what its answer is, right? So in terms of the question, what is the answer to the quadratic x squared minus 3x minus 12 is equal to 0? We now know that the quadratic equation tells us that x is going to be equal to 3 plus or minus the square root of 57, all then divided by 2. And this is by the quadratic equation, which says that for 0 is equal to ax squared plus bx plus c, that x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, this is cool. This always gives you the correct answer. But my one knock against this is that I feel like this requires some memorization, right? You just have to know this cold, or if you're doing your homework, you can just Google quadratic equation if you need it. I like complete the square because I would assert we'll get the exact same answer, except it'll be less memorization. And I'll just start off by writing out the order of the steps for completing the square, and then we'll do it to this as an example.
What do you even need the quadratic equation to solve?
Quadratic equations. This is the quadratic.
Parabolas.
This is the quadratic formula. And just so you know, here's what it's actually solving for. Let's go to Desmos. Okay, so here I'm looking at desmos.com. And if you were to take that quadratic and graph it, you would get y is equal to x squared minus 3x minus 12. So this is the quadratic formula that equation is describing. It's a parabola in real space. Is this okay?
Yeah.
Okay, so when we solve a quadratic equation, what are we setting that quadratic equal to?
0.
We're saying y is equal to 0, which is a flat line. And I don't know if you see it, but it just made it so that the x-axis is blue now. Yeah?
Yeah.
So when you say, hey, set this equation equal to this equation, you're solving for the point where those two graphs meet. So when we use the quadratic equation in order to solve for values, you are actually finding the roots of that quadratic. So here, when we're saying it's 3 plus or minus the square root of 57 over 2, what I'm saying is 3 plus the square root of 57 divided by 2 is this first decimal, 5.275. And if you don't believe me, try it in your calculator. 3 plus the square root of 57 in parentheses, and then divide all of that by 2. You'll get this decimal. And then over here on the left, 3 minus the square root of 57, all divided by 2, gives us negative 2.275 comma 0. And again, don't believe me, punch it into your calculator and you'll get this negative decimal.
Well, yeah, in real life though, where would anyone need a parabola?
Have you ever tossed a ball?
Yes.
And what shape does it, I mean, I'm not just being sarcastic to be terrible, I'm a physicist, so this is always where I go. Have you ever traced the shape that it makes through the air?
It curves.
And it's not just any curve. It's not like whatever curve you want it to be. It follows a precise x squared. It is a perfect parabola whenever you toss a ball through the air. It draws a parabola both over space and over time. And that is a thing that you can solve for using the equations of physics. And when you do physics your senior year of high school or your freshman year of college, you'll get to a point where you have some equation that's blah, 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 x squared plus blah, 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 x. And if you are then asked the question, hey, where does the ball hit the ground? Solving for the roots will tell you how far the ball goes before it hits the ground.
So it can tell you exactly where the ball will hit the ground or something? Or where it will be in a certain moment in time?
Literally, yes. That is precisely what physics is about. Let me show you a video. It's really short. So this is the bullet drop experiment, which is a standard of physics. Oh boy, that video quality, that's something there, huh? It's the resolution is 10 potatoes I. Yeah, there we go. Less potato, right?
Mhm.
Let me just show you all this little video right here. So this is one of the most important one of the most important conceptual experiments in how we think about physics. This is called the bullet drop because at the same time, one bullet is going to be dropped and the other bullet is going to be fired sideways at the exact same time. Now, the way that this is done is without any fancy electronics. It's by clever use of this mechanism. So here on the left, the rod goes through the pool ball so that when the launcher is launched, it drops that ball straight down. And on the other side, that plunger is going to smack into the pool ball. So it launches that pool ball perfectly sideways. And both of these balls are set in motion at the exact same time, right?
Mhm.
What do y'all think out there, those of y'all who are paying attention? Which one of these two balls is going to hit the ground first? The one on the left or the one on the right?
They're gonna hit the ball. They're gonna hit the ground at the exact same time.
We have one vote for they hit at the same time. Are there any other guesses out there?
I think they're gonna hit at the same time as well.
Yeah, me too. I think same time.
It makes sense that they'll hit at the same time, but I feel like the one that's just getting dropped is gonna fall faster.
So I wish we taught physics to freshmen, which, I guess that is what I'm doing right now. My wishes come true or something. The ball on the left is traveling a shorter distance. I'm going to say that first because the shortest distance between 2 points is a straight line, whereas this one over here on the right is going to travel a greater distance. So there are things to consider there. But in reality, gravity acts on all things equally. They're both going to be accelerated towards the ground at the exact same rate. And as a result, yeah, they all both hit the ground at the same time. Boink. One more time. 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 Yeah, they both hit the ground at the exact same time. And when y'all have your first physics courses, either in your senior year of high school or your freshman year of college, you will know one of the answers right off the bat. But here's the deal with the ball being launched out to the right. I'm going to delete both of these. Because I study physics, because that's what I do, I actually know the equations of motion for that for that ball cold as it's launched to the right. That ball is going to fall according to the following relationship. And now I wouldn't, don't ask me why. The reason as to why is something that you'll be taught in coming years. And, you could like look up this video again. It'll still be up, I think. This equation, let me edit it. This equation is a good look at exactly how the ball will, I'm sorry, that shouldn't be there. At exactly how the ball will behave as it flies forward, where v is the initial speed of the ball and h is the height at which the ball is launched from. So notice if it's h, right, and we're only going to stay in quadrant 1, this is saying that the way that the ball is going to move is going to be according to this curve. And v is the speed of the ball. So if I increase the speed of the ball, I think it's pretty natural to have it in your head that, oh, it'll fly further before it hits the ground, right?
Yeah.
And this equation is a quadratic equation. So if you knew the velocity of the ball and you knew the height of the ball, and this 9.81 just describes how much gravity there is on Earth, if you know how to solve the quadratic equations, you could put this all together and know that the ball is going to hit the ground exactly 4.926 meters from where it started.
Mr. Robinson, so when it hits the ground, does it technically hit like the x-axis?
All of this depends on how you set up your problems, but normally we say that we're at a height h above the ground and the ground is 0. It just makes the math easier.
Okay, so if you were to put the quadratic in the vertex formula, would you be able to find like where it would start and where it would finish? Or that wouldn't tell you exactly?
Yes, and the thing that we're about to do, completing the square, is going to put the quadratic into vertex form. Just for your own knowledge there. Okay, all great questions. It's really important to motivate why we would ever care about this stuff. So here's the deal with completing the square. What we're going to do, and this is the way that I think about the steps, is that we are going to, number 1, move C to the other side. Two, we are going to divide both sides of the equation so that A is 1. Then we are going to, and this is the magical step, this is the step that completes our square and makes this method worth studying at all. We are going to add b over 2 squared to both sides, which forms a perfect square factorial. And then the rest of it is just regular old algebra. The rest of it is to solve for x. So instead of memorizing this like slush of algebraic terms, you could just know this method. And I would assert that all of this is pretty natural except for this step. So instead of memorizing all of this jazz, just know that the magic step is taking b over 2 quantity squared and adding that to both sides. So let's go ahead and see how completing the square applies to this quadratic and how it gives us the exact same answer. X squared minus 3x minus 12, well, that's equal to 0. So the first thing that I'm going to do here in order to complete the square is I'm going to move c over to the other side. I'm going to add 12. This is going to give me x squared minus 3x is equal to 12. Is that first step okay?
Yeah.
Yeah.
Okay. Now I'm going to do the magic step of completing the square. I'm going to add b over 2 squared to both sides. Notice this is b, right? B is -3. It's the number that's tacked onto our x. So I'm going to add to both sides -3 over 2 squared. So to this, I'm going to add -3 over 2 squared. Now, here's why this step is special and powerful. This is now a perfect square factorial. This technique will always produce a perfect square factorial. This can now be factored, even though this doesn't factor because it's ugly. I guarantee this step will always force factorization on the left-hand term. This is x minus 3 over 2 squared. I dare you, take this and FOIL it, and if you FOIL it, you will get back this step up here. But down below, to keep moving along, we're going to have to simplify what's on the right-hand side. And so this is going to be equal to 12 plus, what's the rule about squaring a fraction?
You square the numerator and the denominator independently.
So this is going to be plus 9 over 4, because we have to square the top and the bottom separate from each other. Now I'm going to combine this to get a common fraction. And so we'll have to multiply 12 by 4 over 4. So the right-hand side is going to be equal to 48 over 4 plus 9 over 4, which is
57 over 4.
okay. So now we've done the first 3 steps of completing the square. We moved c over to the other side. We divided it so that a was 1, which we didn't really do here because a was already 1 when we started off the problem. We added b over 2 squared to both sides so that it makes a perfect factorial. And now we're on the final step. All we have to do now is solve for x. How do I solve for x? How do I get x alone here?
Square
You
root.
add both sides. I mean, you have to root it first, and then you add both sides by 3/2.
Step one, we have to take the square root on both sides. So I take the square root here, and I take the square root here, and this is going to give me x minus 3/2 is equal to the square root of 57/2. Square root of 57 doesn't simplify, but the square root of 4 is just 2. And what's the square root of 81?
9
That's only half the answer. What's the other square
and
root of 81?
negative 9.
Keep in mind, when you take the square root of a real number, you have to get a plus and a minus. So the square root of 57 is actually plus or minus 57, yeah? And now we're one step away from getting x alone. What do I have to do?
Add both sides by 3/2.
Add both sides by 3/2. So this is going to be x is equal to 3/2 plus or minus the square root of 57/2. X is equal to 3 plus or minus root 57, all then gathered over 2. It gives the exact same equation as the quadratic equation, except if you ever forget this soup of terms while you're taking a test, if you just remember, hey, b/2 squared will make it so that I can factor any quadratic. I believe that this may be more hand math to do, but it requires less memorization if you're in a pinch.
I feel like this is easier.
I agree, and if I was the supreme overlord of all mathematics, education, and science, like I will be in a few years, then I would make it illegal to teach this, and this would be the only method that we teach. Anyway, we have like 15 minutes left of class. This time is yours. So if you've uploaded the homework, great, congratulations, you're awesome. You're free to go to the weekend. And if there's anybody who has any questions on the homework, I'll address those now. And I'll also read off the solutions.
Okay, see you, Mr. Robinson. I turned it in.
Tight. Have a nice weekend.
Bye, Mr. Robinson.
Peace. Have a nice weekend. Happy Friday.
You too.
Bye, Mr. Robinson.
Bye. Have a nice Friday. Actually, this one's pretty straightforward. I'm not going to rattle off all the solutions, but I will read out any specific ones that y'all have. Were there any specific answers y'all were looking for? Or any questions that you wanted me to do on stream?
Oh, Mr. Robinson, I finished. Bye. Have a nice weekend.
Oh yeah, peace. Take it easy. Have a nice weekend. Once it's uploaded, you're free to go.
All right.